All right, so in this problem here, you have your sulfuric acid as one of the acids being used, and you have 1.2 molar sodium hydroxide that's being used to neutralize out your battery acid. And they give you the balanced chemical equation to use. And again, this is an acid-base reaction. There is neutralization going on. And there's two ways that you could solve this problem. One of the ways that we talked about in your notes was just by using this simple equation right here. You know, when you multiply the molarity of your acid times the volume of the acid, this will give you how many moles of acid you have. And your moles of acid are pretty much equal to your moles of base because we know that this is a neutralization reaction. These have to be equal to each other for them to be neutralized. Okay. Now there's one thing to keep note of here. The acid is H2SO4. So this is actually two hydrogens. It's diprotic. And for this one, you have sodium hydroxide with just one OH here. So the two hydrogens actually have to get incorporated into our equation. So it's 2 times the molarity times the volume of the acid. And for the hydroxide, if you just want to add it to this, it's times 1, just because we only have one hydroxide in sodium hydroxide. And the rest of this is just pretty much plugging in whatever they gave us in the problem. So we have 2 times the molarity of my acid, which is 3 moles per liter. The volume of the acid is 0.225 liters. I had to convert milliliters over to liters by dividing by 1,000. The molarity of the base is 1.20 moles per liter. And the volume of the base is what you're actually going to be looking for. So to solve for VB, we're going to take everything on the left side, multiply it, and then divide by 1.20. So I'm just going to actually rewrite this just to make a point that I'll show you later. 0.225 liters, and then we're going to divide by what we have. And if you take this out and you multiply everything and then divide by the 1.2, see what we can. Actually, don't have that calculated yet. So 2 times 2 times 3 times 0.225, and then divide that by 1.2. So 1.125. And we need the smallest number of sig figs in our answer, so we could round that off to 1.1 liters of our base is what's required. Now, another way to set up this problem if you do not want to use this equation, although it is easier, you could also set it up using stoichiometry. And we could say that we know everything about our acid, though that becomes my A. And my B is going to be how many liters or milliliters of your sodium hydroxide we're going to need to get to. So if I set this up that way, you're just going to take your 225 milliliters of my acid, and this is just using our roadmap. It's 1,000 mils of my acid over 3 moles of H2SO4. We have 2 moles of sodium hydroxide over 1 mole of this. And remember, from this, we actually are going to be using our coefficients of 2 and the 1 right here. And that gets incorporated into my equation. Now, I think a lot of you guys had some questions where you kept on putting in the coefficients into this equation. But remember, the coefficients only get utilized when you're doing stoichiometry this way. But you will eventually see that why it's actually the same thing. So we're trying to get it out to volume. So I'm just going to put 1 liter on top, divide by 1.2, which is the molarity of the sodium hydroxide. So these cancel, and we end up getting liters of sodium hydroxide. And if you take a look at what we did up here, you're actually doing the exact same math down here. We have 2 times 3 times 0.225, so that's 225 divided by 1,000, and then we divide it by 1.2. So really this equation that you guys were using up here for the molarity of the acid times the volume with the molarity of base times the volume of the base, it's pretty much doing stoichiometry. So just remember here that when you're putting in the 2 and the 1, these actually come from the subscripts in the equation. But then when you're doing stoichiometry, the 2 and the 1 come from the coefficients of the equation. And they are on opposite sides in the equation, but they really come out to the exact same thing when you're doing the math. So you wind up with 1.1 liters of sodium hydroxide as well.